Hey class, we get to do some fun stuff today. Solve linear systems by just graphing. That's the easy kind. Let's take a look. So a solution is basically where the two graphs intersect, or two lines intersect. That's the solution because of the x and y for both equations. Let's take a look. Graph a linear system and estimate the solution, then check the graph or the solution algebraically. So you go ahead and you graph, you get your zeros, put them in, and get your 2 points to create a line in both these situations. Then we can go ahead and look to where they intersect. Now we look over here, here's the 2 lines, we graph their zeros, and we found that they intersect at 3, -4. That has to be the point that they both have in common. They both have that x and that y because it's on both lines. So let's try it out. Place a 3 in for x. 3 times 4 is 12. Place a -4 in there. Now I'm going to show you that on the next screen. So you plug in the 3 and the -4 into the first equation. You plug the 3 and the -4 into the second equation. And as you go through the algebra, you find both are actually true. So the goal is, once you find a solution, substitute it back into both and see if they turn out to be true, like 8 = 8 and 18 = 18. If they're both true, then you know for a fact you found the solution to the 2 equations. All right, let's take a look at this. Graph the linear system and estimate the solution. Then check the solution algebraically. So you're going to go ahead and you're going to grab your piece of graph paper and you're going to graph this line, 3x + 2y = -4. I would suggest you use your x-intercepts and your y-intercepts by plugging in 0. Okay, pause your video after you've graphed these, write down the solution, and let's see if it's true. Welcome back. Let's see. If I graph these two, they look like this, and they intersect at -2, 1. Now, if I plug -2, 1 into both of these equations, it will turn out, so the answer is -2, 1. All right. Oops, sorry. All right, I would like you guys to graph these 2 equations, pause your video, graph the 2 equations, see where they intersect, and that should be the solution. Pause your video, give it a try. Welcome back. Let's see. Did you graph them, and did they look like this, where they actually, let's see, 1, 2, 3, 4, 5, -5, -2 is where they intersect. So if that's where they intersect, that has an x and y for both equations, and yes, that's your answer. All right, one more try. Graph these 2 equations, and let's see where they intersect, and that should be the solution. Pause your video, give it a try. Welcome back, and voila, they intersect at 0, -8, so that's the solution to both equations. The system of equations, I should say. All right, now we have to learn a little bit of vocabulary here. If you have exactly one solution, like what we've just been practicing, the lines intersect at one point. It's considered consistent and independent. Now, if you have one line and it lands on top of the other line, that means there's infinite solutions. They're consistent and they're dependent. Now, if you create 2 lines that are parallel, they are not consistent. In other words, they're inconsistent. They're never going to intersect. So let's review this. If they intersect in one point, they're consistent and independent. If they intersect all over the place, in other words, it's the same line, they're consistent and dependent. If they never intersect, they're inconsistent. All right, let's give it a try. Solve the system, then classify the system as consistent and independent, consistent and dependent, or inconsistent. Now remember, consistent and independent, they intersect one point. Consistent and dependent, they're the same line. Inconsistent, they're parallel lines. All right, graph these 2 lines. This is what we do. We go graph the lines, and there's that one. Oh, pause, dog barking. Okay, I'm back. Let's see. These 2 lines, look at that. They're right on top of each other. Well, that means they are going to be consistent and dependent. All right, let's try another. Yep, jumped one. Okay, we graph these 2 lines. Oh, they're parallel. Well, if they're parallel lines, we get consistent and dependent. Nope. we get inconsistent, guys. They're inconsistent. They're never going to intersect, so they're inconsistent. And voila. Now, you guys give it a try. Graph these two lines, and then let me know if they're consistent independent, consistent dependent, or inconsistent. Pause your video, give it a try. All right, I expect to see those graphs, but guess what? There's no solution. They're inconsistent. They are parallel lines. Try to graph these two lines and decide consistent and independent, consistent and dependent, or inconsistent. Pause your video, graph the two lines. Welcome back, and look at this. They are the same line. So they're infinite many solutions, consistent and dependent. Now, there's a quicker way other than graphing just to know this, so you know. If I do 2 times 2, I get 4. 2 times 5, I get 10. 2 times 6, I get 12. Ha! It must be the same line, guys. All right. Well, let's graph these two lines and see what they are. Pause your video, give it a try. Welcome back, and look at this. They are consistent and independent. They will intersect only in one point, and that point is at -1, 3. All right, that's it for today. See you guys tomorrow.